Most people in the world of math have heard about Srinivasa Ramanujan. While living under British colonialism, he taught himself higher mathematics despite being disconnected from the advanced mathematicians of the time and made significant contributions to research that mathematicians are still studying and exploring today. Here were some of the most interesting discoveries Ramanujan has made. The Ramanujan constant. First, e to the power of pi square root 163, which is called the Ramanujan constant, is approximately equal to this large number. The interesting part of this is that e and pi are transcendental numbers, but putting them in this expression makes something extremely close to an integer. This actually was discovered by Charles Hermite 50 years earlier, but people now informally call it Ramanujan's constant because of an April Fool's joke in the Scientific American, where the author claimed Ramanujan predicted that e to the power of pi square root 163 is an integer. Although Ramanujan didn't specifically find this, he did also discover other almost integers, such as e to the power of pi square root 58. Nested radicals. Once Ramanujan published the problem square root of 1 plus 2 square root 1 plus 3 square root 1 plus so on in the Journal of the Indian Mathematical Society and waited for 6 months over 3 issues to receive any solution, but he never got one. The idea was to solve this problem by breaking down 3 into infinitely many radicals, as 3 equals square root of 9, which is equal to 1 plus 2 square root 16 equals square root of 1 plus 2 square root 1 plus 3 square root 25, and so on. It also turns out that prior to publishing the equation, Ramanujan had already figured out the generalized solution, where x plus n plus a is equal to the square root of ax plus n plus a squared plus x square root of this expression, as it keeps going on. And so, the original problem could be solved by just setting x equals to 2, n equals to 1, and a equals to 0. Meanwhile, Ramanujan's next discovery is still used today in some of the fastest algorithms. Series for 1 over pi. Using elliptic integrals and the modular lambda function, Ramanujan discovered that 1 over pi is equal to this summation. This series converges extremely fast, where each increase in k gives about 8 more digits of pi, which is why it's still used in the fastest calculations of pi today, in the Chernovsky algorithm, which is based off of this formula. Rogers-Ramanujan identities. The Rogers-Ramanujan identities look very hard to read, but can be explained simply. To understand them, you need to know partitions. A partition is a way you can split up a number into smaller sums. For example, if you take 8, you can split 8 up into 4 plus 2 plus 1 plus 1, or 5 plus 3, just to name a few, but there are many more. The Rogers-Ramanujan identities determined a way to count the number of partitions in specific cases. The first equation says that the number of partitions of n where adjacent terms in the sum have a difference of at least 2 equals the number of partitions where each part, when divided by 5, leaves a remainder of 1 or 4, which is also said in math terms by congruent to 1 or 4 modulo 5. The second equation says that the number of partitions of n where adjacent parts have a difference of at least 2 and where the smallest part is at least 2 equals the number of partitions where each part, when divided by 5, leaves a remainder of 2 or 3. These equations have a very interesting backstory. They were first discovered and proved by Leonard Rogers in 1894, but his papers were ignored. Meanwhile, a few years later, Ramanujan discovered these equations but didn't have a proof for them, and only discovered Rogers' papers in 1917. However, on the side, Isai Skur, without knowing of these, independently discovered and proved these identities in 1917. To this day, no one knows where Ramanujan got these formulas from. Some believe it can only have come from divine intervention, as Ramanujan himself claimed he got these insights from the goddess Namagiri. Others, however, believe that Ramanujan's brain was special and allowed deeper intuitions than normal. Whatever the explanation, mathematicians to this day are still trying to understand and apply the ideas in his notebooks from more than a century ago.